Hi there. Let's look today at factoring trinomials by grouping. Now we've done the factoring by grouping already, but when you did factor by grouping you had 4 terms. We're going to look at trinomials where there's only 3 terms. And I just want to preface this with, this is really the same thing that you have been doing previously, just a different way to do it. We're just factoring. And if you struggled with the trial and error, this is maybe another option for you. I got to be honest, I kind of feel like if you just know one way or the other, you're going to be good. And this is kind of maybe breaks it down a little bit easier for some people. For some people, this is going to be harder. You choose what works best for you and go with it. But this is going to be a tutorial on how do you do factoring by grouping when there's only 3 terms there. Well, the trick is to get it to be 4 terms. We're going to turn it into 4 terms. So then we'll just do the factor by grouping. To get it into 4 terms, we're going to take this negative 31c, and we're going to split it into 2 separate terms that would add up to negative 31c. We're just going to kind of spread it apart. To get that, and I just thought we would just maybe do like 3 examples, and hopefully after 3 of them you kind of get the hang of it. You might want to take some good notes. I pulled these problems straight off of your practice off of the software. The first step is going to be to multiply your first term times your last term. We call this A and this is C. The equation is really a trinomial, looks like this: ax squared plus bx plus c. A is always the coefficient on your x squared, or in this case c squared. C is always the constant, b is always that middle term. The first thing you're going to do is take your a times your c. In this case 8 times negative 4. When I multiply 8 times negative 4, I get negative 32. And I'm ignoring the variable right now, I'm just looking at the coefficients. Once I multiply the a times the c, I am looking for a number that multiplies to get you a negative 32, and I say a number, I'm looking for 2 numbers that will multiply to negative 32 and add to whatever your b value is, in this case negative 31. And then we just kind of figure out what could I multiply to get a negative 32 and add to get a negative 31. And think about it a minute, and you should come up with, oh, I could take a negative 32 times a positive 1. That would multiply to negative 32, and when I add these 2 numbers up, they get me a negative 31. I've got it. Those are my 2 numbers. Sometimes this is easier to come up with. Instead of doing the trial and error, the guess and check business, this is going to always be the correct set. It's not like you have to try it and then it doesn't work, try a different one, it doesn't work. This will always be what works. The downside, and you'll find this on your homework, is that sometimes when you multiply your a times your c, this gets to be a pretty big number. And sometimes it's hard to find factors that will multiply and yet still add up if you start getting huge numbers. Just something to throw out there. Now, once you find the correct numbers, you're going to take this b value here and you're going to separate it into 2 terms. My equation is now going to look like 8c squared. And instead of minus 31c, I'm going to write minus 32c plus 1c. You should be able to look at this and say, oh yeah, that I would simplify that, and that would simplify to this right here. I'm just separating it out. The last term, the minus 4, still sits there. What you've managed to do is turn your trinomial into an equivalent polynomial with 4 terms. And then you treat this like you did previously on a previous lesson when you did factor by grouping, where you put parentheses around the 2 sets. If I put parentheses in here, and then I'm going to factor out the GCF on each one of those. I'm going to pull out an 8c. I'm left with c minus 4. Plus, On this one, I'm going to factor out a 1. I need to factor at least something out, so I'm going to pull the 1 out, which would leave me with a c minus 4. Recall that what we're trying to do is get these two quantities to be the same. They are. What's really going on here is you have this big term here, because you got your 8c times your c minus 4, that big old term, and this big old term that you are adding together. And you look and say, well, look, they both have a c minus 4. Let's factor the c minus 4 out of each term. When you factor c minus 4 out of this, we have 8c left, plus, when you factor the c minus 4 out of this big old term, you have a 1. And those are your factors. Again, it's a little bit lengthier of a process, but it's not having to guess and check, and so if that was a struggle for you, this you might like the more tried and true, works every time deal. We're going to try a few more of these. One of the things that I didn't address on the previous problem was pulling out a GCF. You do need to always look to pull out a GCF. On that previous one, there wasn't a GCF, but this one does. You're always going to look to pull that out way out in front, so this has a 3p as a GCF, which then becomes 3p squared plus 2p minus 1 in my parentheses. Following the same steps as the previous problem, we're going to multiply the a times the c, and we're going to look for factors that multiply. We're going to multiply to -3, and they also have to add to your b value right here. Two numbers that multiply to -3. I don't have very many options. It's pretty much going to be a 3 and a 1, but since it's a -3, one of those has to be negative. I want them to add up to a +2. That means this is going to have to be the negative. Multiplies to -3. If I were to put a plus sign in between there, 3 plus -1 is a +2. What you're finding are the two values that you can separate this middle term into two parts. As we deal with this GCF, this guy, he just keeps coming down. You just bring him down, and he always stays out in front the whole time. I'm going to put that 3p out there. And then I'm going to rewrite my equation, 3p squared, but I'm separating the plus 2p into a plus 3p and a minus 1p. Those could combine to get me that positive 2p. And then my last term doesn't change, it's still a minus 1. 3p stays way out in front, ignore it, and look to do factor by grouping. I threw another little quirky thing in here. Remember that if this is a negative, you have to be careful with that, because when you put in your grouping symbols, you always want it to be a plus sign between there. I'm going to change that to plus a negative, so it stays negative, but then when I put in my parentheses for grouping, I have a plus sign in the middle. And now pull out a GCF. On the first one, I can pull out a 3p, and I'll be left with a p plus 1, plus sign in the middle. On the next one, I can pull out a -1, and then I'd have a positive p plus 1 in parentheses. The parentheses set match, so I'm good to go. I'm going to write my p plus 1. As I factor it out of each term, I have a 3p minus 1. But don't forget, this 3p that we factored out has to be in the final answer. So often people miss this because they forget to put that GCF back in at the final step. Keep it in there. That's part of your answer. Okay, let's try one more. I tried to pick a crazy one so that we do one that, you know, sometimes it feels like I always do the easy ones and the hard ones are on the homework. I picked a hard one because there is a crazy amount of GCF to pull out of this. That's really all that makes it tricky. Let's make sure we get the GCF factored out. It looks like they're all even numbers. 2 would go into all of them. But I don't like my first term to be negative. I'm going to go ahead and pull out a negative 2. But that's not all I can factor out. All of them have some W's. This one would have 4 that I could factor out, but this one only has 3, so I could do at most 3. But this one only has 2. I'm going to pull 2 out. That's the most I can get out of there. But if you look at the x, this has an x, this has an x, this has an x. Let's factor that out also. When you factor out the GCF, this actually breaks down to a pretty decent little problem. This is going to be a positive 5. I did have a w to the 4th, but since I pulled 2 of those w's out, it's only a w squared now. And the x got factored out. Minus, oh, wait. Since it's a negative 6 divided by that negative 2, it's really going to be a plus 3. It was a w cubed, but since I factored out 2 of them, there's only going to be 1 still sitting there. And the x is gone because I factored it out. And the last term, I've got a positive 4 divided by this negative 2 is going to get me a negative 2. And the w squared and the x both got factored out. Now that's a nice little polynomial there. Or trinomial. I guess this one's a trinomial. And our goal again, we're going to take the a times the c, and we get negative 10. And I'm looking for factors that will multiply to a negative 10 and also add to your b value right there. Well, I don't have a whole lot of options. What multiplies to a negative 10? It's probably going to be a 5 and a 2, but one of them is going to have to be negative. Do you know which one? Since I want to have a positive 3, when I add them, I'm going to want my 5 positive and my 2 negative. That would multiply to negative 10, but if I wanted to add it, it'd give me a positive 3. Let's rewrite this trinomial with 4 terms where we separate the 3w into 2 terms. Don't forget that the negative 2w squared x, that GCF that we factored out, has to keep coming. And then I'm going to have 5w squared. Separate the plus 3w into a plus 5w minus 2w. And the minus 2 at the end stays there. It now has 4 terms, and I'm going to group it, but again, remember you're going to want a plus sign between your 2 groups. I'm going to change that to plus a negative before I put in the parentheses. Keep your GCF out here, and then you pull out your GCF on each one of these. I'm going to pull out a 5w, which is going to have a w plus 1 left, plus, on this next one, I'm going to pull out a negative 2, which means I'll have a w plus 1. That's good news. Those match. Factor out the w plus 1. Write the leftover. 5w minus 2 is the simplest way to write that. And leave your negative 2w squared x out in front. And we're done. Now, I actually edited this problem from your practice. This one worked beautifully. I wanted to go through one that worked beautifully even though it looked scary at the beginning. What I want to do is I want to tweak this back to what it was originally when I pulled it off of the software. It actually was this problem, and it had a minus sign right there. That means when I factored out my negative 2, this would have been a plus instead of a minus like on that previous example. Then we take a times c and we'd get 10. And we're looking for factors that multiply to 10 and add up to 3. Multiply to 10 could be 2 and 5. But since it's a positive 10, I don't get to make one of them negative. I'd have to make them both negative. But I don't want to do that because I want a positive 3. The problem is 2 plus 5 does not equal 3. It multiplies to the 10 like I want it to, but it doesn't add up to the 3, which means 2 and 5 aren't correct. But if we had instead tried 10 and 1, because 10 multiplies, 10 times 1 works, but 10 plus 1 is not 3. Sometimes it's going to give you that option to say not factorable. This might be something that we could write not factorable, except that we did factor it a little tiny bit. We pulled out a GCF. I would not call this totally non-factorable. This is actually the answer that you should enter into the software because we did factor it, because it happened to have a GCF. If we didn't have a GCF and we were only given this problem right here, and when we did the AC it got to 10 but I couldn't find any factors that worked, then I would say not factorable. Be looking for that. Sometimes that is actually the answer, not factorable. But if there's at least a GCF, then we've factored it, and you just write that as your answer. All right, hope this helps on this lesson.